number 4. There we go. Question number 4 is asking what is a 30, 60, 90 triangle? Okay, so this 30, 60, and 90 represent degrees. So if we have 30, 60, and 90, we have the 30 and 60 as interior angles. Well, they're all interior angles, I guess I should say, of a triangle. And with the 90 degrees, you know that it has a right angle, or it's a right triangle, right? Because 90 degrees makes a right angle. So let's draw this triangle. Might look something like this, where we have 90 degrees in this corner, 30 degrees, and 60 degrees. Okay, so 30, 60, 90 triangle is a special type of right triangle. It has interior angles 30 degrees, 60 degrees, and 90 degrees. This type of triangle is special due to the relationship between its sides. So knowing a value of just one side will allow us to calculate the values of the other two. So let's try to work that out, okay? So if we start off with an equilateral triangle, which means a triangle with that has all the same length sides. So in this case, we're going to say x as the length of the sides, and each angle, interior angle, is 60 degrees. If we were to split this equilateral triangle, let me just label it here, equilateral triangle. If we were to split this equilateral triangle down the middle so that there is a 90-degree angle with this intersection and the bottom of the equilateral triangle, then we would be able to get our 30, 60, 90-degree angle triangle, the one that I said before, right? So let's draw it out. We have 30 degrees, 90 degrees again, and 60 degrees. Okay, and this is the other half, right? But we don't need to draw that. So we know that this side length here is x, and if we, along the bottom here, cut it right in half, then we know that this length of this side is x divided by 2. Because right, you cut it right down the middle. Now all we need to know or figure out is the length of this new side, right? So what we can do to come up with the length of this side is we can use Pythagorean theorem. So Pythagorean theorem states that if we have 3 sides of a triangle, we have a squared plus b squared is equal to c squared, where we can say that this is c, because c always has to be opposite from the right angle, and then I think you can probably just use whichever you prefer for A and B. So I'm going to write A for this unknown side length, and then B for x over 2. Okay, so let's use Pythagorean theorem to figure out A. So let's rearrange the equation for A. So if we want to know what A is, we can say A squared is equal to C squared minus B squared, and then take the square root, and we have A is equal to the square root of C squared minus B squared. Okay, and we know what B squared, or B and C are from our triangle. So we have the square root of x squared, that's from here, minus, for B we said B is equal to x divided by 2, square that. Okay, now we can combine 2, so we have x squared minus x squared. Let's square everything inside the bracket. So we have x squared over 4, and then we can add the fractions. So if it's just x squared, we can imagine that it is 1 over 1, right? So 1, if we want to add the fraction, we can multiply it by 4, so it's 4 over 4. Sorry, that might not be clear anymore. Okay, and then 4 minus the 1 from here, we have 3 over 4, x squared. If you're unsure, you can go through that 1 minus 1/4 again. But yeah, you will get this. And then if we apply the square root, you can't take the square of 3 without getting rid of the integer. So we'll just leave it as the square root of 3. But the square root of 4 is just 2, and the square root of x squared is just x. So we get that side A is equal to square root 3 over 2x. So now we have our completed triangle from up here, right? We know what a side length A is now. So let's draw our final known triangle, okay? So if we have 30 degrees, right angle, and 60 degrees, we knew from before that this side is x. A, we now found out that A is equal to root 3 over 2x, and the bottom side, or the bottom length here, B is equal to x over 2, which we knew before as well. Alright, and this is our special triangle. So basically what that means is with this special triangle, our 30, 60, 90 triangle, we can basically be given any one of the lengths of these sides and figure out the lengths of the other sides. Okay, so let's go through an example. So if we're given the example, let me make it different this time. So if we have our 60, 30, 90 triangle, and they give us one side that is 8. Here, I'll just move down. I think this is part of the question. So here's our solved triangle that we found with Pythagorean theorem. And here is the example. Okay, so we have B and A. Okay, so the only side that is given here is 8. But we can find out what B and A are just from the one given side. So remember, we figured out from before that B is equal to, well, they switched around the letters. Usually I would prefer because when you're using Pythagorean theorem, you need C to be the one across from the 90 degrees. So I'm going to change this to C because that's, you're going to need to use it as C anyways, and I don't want you getting confused. So we'll say that we need to find what B is. Okay, so we know that C, using our special triangle up here, we know that C is equal to X. A Well, don't get confused because now the 60 degrees and the 30 degrees are flipped from this special triangle that I have drawn up here, right? So the way that you reference the sides is the side that is across from the angle. Oh, I realize I'm talking crazy here because I labeled them wrong. So this is the 30 degrees and this is the 60 degrees as per the way I drew the triangle. Okay, now you can see that they're flipped, right? We have 60 degrees on the bottom and 30 degrees on the bottom in our example. Okay, so now we have to learn how to apply this rule I'm about to talk about. Okay, so A is going to be so A is across from the 60 degrees, and in our special triangle here in green, we see that across from the 60 degrees we have root 3 over 2. So that is how we know what side we're talking about. We're referencing it by the side that is across from the angle, okay? So A is equal to root 3 over 2, and then B, which we know is 8, this side is across from the 30 degrees, and in our special triangle, the side length that is across from 30 degrees is x over 2. Okay, so since we can't get anything with this one or this one because there's unknowns, we can figure out what x is though from our given side length, right? So if we're given that this side is equal to 8, then we have x over 2 is equal to 8. And if you multiply both sides by 2, you get x is equal to 16. Wow, okay, so now we can pretty easily find out the other sides, right? So C is equal to x. Well, we just figured out that x is equal to 16. And A is equal to root 3 over 2x. So all we have to do is take root 3 over 2 and substitute in 16. And 16 and the 2, or 16 divided by 2 is 8. So your answer for A is root 3 times 8, or you would usually write the 8 out in front just so that it's easier to see the separation there. Okay, so now we have solved the entire triangle. So I'm just going to redraw the triangle with all of our known side lengths now. So we can find or see the solution. So we take, oops, I'm drawing it wrong again. We have 30 degrees on the bottom, 60 degrees the top, your 90-degree angle. We just found out that C is equal to 16. A is equal to 8 root 3. And B is the given angle, which is 8. All right, and that is the final solution. So we were able to see both what the 30, 60, 90-degree angle triangle is, like how we got to it from an equilateral triangle and the Pythagorean theorem, so that we were able to find this special triangle. Label it special triangle, meaning that if we are given one of the side lengths, we are able to find the other two side lengths as we saw in this example. And that's it for this question. All right, so we get the same answers. We have angles of, the side lengths of 8 root 3, 8, and 16. So that's correct. And we can move on to the next question.